Now, in the past, we have discussed the topic of encapsulation. Now, what exactly is encapsulation and how does it work? That is what we want to understand today. Okay. Now, encapsulation, we will try to look at a practical use of this concept. Okay. And what we are going to focus on today is hyperparameter tuning and how we can automate it. Okay. Automation is a big deal in the industry. It just makes your life very easy. And that is exactly what we are trying to do. We want to look at concepts like grid search or random search and how we can use encapsulation to automate that entire process. This is the agenda that we have. Okay. So now let's try to understand this concept. Okay. And let's see what we can do with it. Okay. So now using our object-oriented approach, we will try to see where exactly will the parameter tuning come into the picture. Okay. So this is the agenda at hand. Okay. So let's just get into it. We will start by importing our libraries, basic libraries, nothing complex. Okay. And we want to use some libraries from our SQL. And here we are going to look at grid search. So let's import the necessary libraries. So we will take grid search and we will take random search. Okay. And we will also just import the matrix. Okay. Which is our accuracy score. Now, this is all basic concept that we follow, right? Now, what we want to do here is we want to automate the process here. Okay, this is what we want to do. So we have a basic outline that we want to follow. The outline is as defined. We have the hyperparameter search class. Okay, we have the encapsulation of specific search strategies. We have parameter storage. Excuse me a minute. So, sorry about that. So we want to encapsulate specific search strategies, right? We want to look at parameter storage and management, and we want to look at the logging and analysis of our results. So the first thing that we want to do here is we want to define a base class. which is again a very important concept. Okay. Now, what exactly do we want to define under this? We want to define the structure that outlines the general structure. Okay. So, whatever hyperparameter tuning we need to perform, we can use the base class to define that structure. Okay. So, this will contain methods. Obviously, we need methods within the class. And what are these methods going to be about? They will be about model fitting, scoring, and logging the results. Okay, this is what we want to do as part of our base class. Okay, so let's take a class, right? And let's call this class hyper parameter tuning. Okay, a mouthful name, but it is quite exact. Now, within this class, the first thing that we want to do is we want to initialize whatever requirements we have. So we will initialize everything. Okay. So we'll call self, we'll call the model, we'll call the parameter grid, and we will also define the scoring method. And we are going to give a default value there. The scoring is going to be on the basis of accuracy. Okay. Now, here what we will try to do next is we will try to write a doc string. Now, what exactly does this doc string do? This doc string will enable us to this doc string will enable us to understand, but not just you, anybody who does it. It will enable them to understand what kind of parameter tuning is required. Okay, so let's define a string here. And here we will define what are the parameter model which we will use. So within the parameter model, we are going to say that this is just going to look at some basic machine learning models. Okay. Then what is the parameter grid that we are defining? Now, what exactly is parameter grid? Parameter grid is nothing but a dictionary which contains the model hyperparameters. What are these hyperparameters? These are the hyperparameters that we want to tune. And then what is scoring? This is just the metric of evaluation. Okay. So this is how it is going to work. Then we will initialize our model. We will initialize our parameter grid. Okay. We will initialize the scoring. Okay. We will initialize the best parameters which we extract after we do our hyperparameter tuning, and we are going to initialize it as none. Okay. And then the same thing we will do for the best underscore score, which we are going to initialize as none. Okay. Now, this is just initializing all the values that we require. Okay. The next thing that we will do here is we are going to define the various methods. So first method that we have fit. So here we will define our X train and Y train. This is what we want to fit our machine learning model. So we are just defining all the steps that we are doing here. And we can just raise a not implemented error. Okay. And you will say this method needs to be implemented by the subclass. Okay. Then we are going to define a grid of best parameters. Okay, so we'll create another method. And we will return the best parameters. Similarly, we will also define another method to get the best score. And we will return self dot best score. Sorry, not best parameter, but rather best score. So this is our base class. The next thing that we want to do is we want to implement some subclasses for grid search and random search. Okay. So let's implement those classes. So the first class that I want to implement is my grid search theory. Okay, so I will say grid search unit, and I will refer to my base class. Okay, within this, we will implement the fit method. Okay, so this was something that we mentioned initially, and we mentioned that this has to be implemented by our subclass. Okay, so what do we want to implement here? The first thing that I want to implement here is a grid. So I want to implement a grid search. Okay, and we will call our grid search CV. And within this, we will call the various parameters like estimator. What is the estimator? Which is going to be self.model. Okay. Then we have our parameter grid where we are just going to define self.parameter grid. Okay. Then the next thing that we want to implement here is our score. Okay. So again, we will just say self.scoring. And for CV, we will mention for cross validation, we will mention the standard value of 5. Okay. And then we will say grid.fit our xstring and ygen. Okay. Then next, we will call the best parameters. Okay. And we will get the best parameters from this grid that we have created. Similarly, we will call the best scores. We are going to get this best score from this grid that we have implemented. And what do I want to return? I want to return the best estimator. Okay. So best estimator. Done. So this is the class that we are defining for our grid search. Okay. So this way, next time when I call the grid search function, I can directly just implement the grid search. So now let's take a look at our random search. Let's start writing our class for our random search. And again, we will call our base class within the subclass, right? So now random search works differently than grid search. Let's say that we have two sets of parameters, P1 and P2. P1 takes in 3 values, ABC. P2 takes 3 values, 1, 2, 3. Okay. Now, if I was to create a grid of this, The total possible combinations that I can have is basically 3 into 3, 9, right? So I can have a total of 9 combinations. So here we will say A1, A2, A3, then we say B1, B2, B3, then we'll say C1, C2, and C3, right? Now this is the possible parameter grid that we have created. Okay. So here, when I want to implement something, right? If I was to implement grid search on this, it will just go through all the possible options in this grid and do an exhaustive search. Once it gets through all of them, it is going to give us the best result. However, when we are trying to do random search, in random search, let's say that when we are trying to do random search, right? You have to define the number of searches you want it to do. Let's say n equals to 3. So what we'll do is it will just select randomly some parameters and it will give you the best result out of that. Okay. So this way, you're reducing the time it takes for you to do the search. But at the same time, you are also missing out on what could potentially be the best result. So when we are talking about the comparison between grid search, right? Grid search is exhaustive. It will try each and every parameter. Okay. Whereas random search will select randomly. Okay. Grid search is slower, but you are guaranteed the best result. Random search is faster, but you may miss out on the best result. Okay. This is how a grid and random search work. Okay. So now let's implement our random search method here. Okay. So again, within this, we will call the fit method. And here we are again taking our X train and Y train. But the thing that we need here is the number of iterations, which are 10. Okay. So here we want to perform randomized search. Okay. And X train and Y train are obviously our training data set. It is the n iter, which is the new parameter. And what is this? This is the number of parameter settings sample. So we are saying that from whatever is the potential total number of parameters, we will sample a total of 4. Okay. So again, we will define a random. And again, I will call my random search CV. And let's get the parameters. So the estimator is the model. Okay. Then the parameter distribution. Okay. So we have to call the variable name as parameter distribution here. So we will call this parameter grid. Okay. Then next, I want to look at scoring, which we will call the scoring method that we have defined earlier. Then the number of iterators, which will be as the number of iterator. Okay. Then we will do cross validation. And just for the importance of storing the variable split, we will call our random split. So these are the parameters that we need to define for a random switch. Then we will fit the data on X train and Y train. Okay. Then we will get the best parameters from our random variable. Okay. And similarly, we will return the best score of the variable. Okay. And then what do we want to return? We want to return the best estimator. Okay. So this is how we can define our class. Now let's save this file. Okay. And we can save it anywhere that we want. Okay. Now, how to use this file? Actually, the process of using this file is very straightforward. Okay. So I will open this folder where I saved it. Okay. So here you can see the file parameter.py. Here I'll create a new file, which we'll call it as sample.py. Okay. And here we will say import. So first we will take some libraries from scalar. And here I'll just take a basic random forest classifier. Then we will take a data set from sklearn as well, just so that it is easy for us to do it. Right? You can obviously try on different data sets. Okay. And then from sklearn, we will also take our train test split. Okay. The next thing that I want to do is I'll say from parameters, which is the name of my file. I'll say import, and then I will say star. So I want to import all of the values from the parameters. Okay. And then the next process is simple. We will just load the data set, and we will say return XY as true. Okay. Then we will do our train test split, X train, X test. We also have our Y train and Y test. Okay. And we will call the train test split. We already have our X and Y. Okay. And here I'll say that the test size should be, let's keep it as 0.2. Okay. Then I'll define my parameter grid. Okay. Within the parameter grid, I will take the values that I want to define. For example, n estimators. Okay. Which is a list of values 50, 100, 200. Then I will take max. This string should be only limited to the name of the parameter, because we are creating a dictionary here. Then I will say max depth, okay, which we are going to define as none. 10, 20, 30. Then I will also define one more parameter, which I'll say is minimum samples split. So which parameters to define? Obviously, you should know the documentation to understand where these parameters are coming from. Okay. So let's create our grid search parameter. Okay, first I'll say grid search. And within the grid search, I will call grid search tuning. You can see that it is a separate file, but because I've said to import all the functionality from my parameters file, it is able to do this. Okay, so here I will define my random forest classifier as well as my parameter grid. Okay, then we will take the best model out of this. Okay, and here we will say our grid search, which is the variable which contains the file. We will fit it on our X train and Y train. And we can also define the number of iterations that it needs to go for. We will say 5. Okay. And that's it. Okay. Then you can do a quick print statement here just to check the best parameters. And it will give you the list of best parameters. So we will say grid underscore search dot get best params. Okay. So this is how our code can be written. Now, what I can do next is I can run this file. Okay. And here we are getting an error. So let's check from grid search. We are getting an error. Okay. So we will go to grid search. We will see. So in grid search, we don't need to define any kind of iterations, right? That's why we are getting this error. So we will do this. We will save the Python file and we will run it. Okay. So it's running now. It started debug. So we will say Python. First, we can check if the file is present, right? Do we have our sample.py? We do. So we can just say Python sample.py. And it has started running now. So it will start doing the exhaustive search that we talked about. As we have mentioned, this exhaustive search is going to be very, very comprehensive. And here it takes its time, but we get the out. Now, similarly, at the same time, you can do the same approach with the random search, and based on this, you can get the output. Okay. So this is the benefit. Okay. Right. So that's all we have for today. This is how we can do encapsulation. So thank you so much for everyone who joined in, and we hope to see you next week.